I have a mean joke for that one. If it's on the video, we'll tell the joke. It's a mean joke. It's not nice, but it does make me laugh a little. I had a math professor from Utah State. His name is Jim Cangelosi. He said to us one day as we're doing this kind of stuff, it's like just, it's this, right? It's just a mess. Like stuff everywhere, And he says, hey, look, let me tell you why you do this. It's because someday you're going to meet some person that just bugs the heck out of you. Because they're just cocky, arrogant, and they're always putting you down. They're just not nice, right? And they're going to come up when you're doing your work here, and they're just going to laugh, say, oh, what an idiot you are. Like, why do you even do that? Like, this is stupid. Like, who can understand all that? Like, that's the dumbest thing ever. Like, like, who in the world can understand? Like, how do you understand that? And you just turn to them and you say, simple. I'm a genius. You're a moron. So, moving on.
All right. That's right to the point.
Right.
I really am.
Here's what I say. Jake Reese, when he was doing the school newspaper, he asked me to write an article one time. Just like a little guest commentary column, So I guess I was a little bit arrogant. I was. So I wrote a column, like why study math? And I'm not saying you need to study math. Okay? Like there's lots of good things to say. I want you to study what you want to study. I have students all the time, they apologize to me. They come back to say hi, and they're like, I'm sorry, I'm not majoring in something math related. I'm like, I don't care. I want you to be happy. I want you to be happy. But I also don't want people making fun of me because I chose this field, right? And so my little column said, why study math? It's pretty simple. Let's see. Of the 500 CEOs of the Fortune 500 companies, like the biggest, most successful companies in America, guess what? More of those CEOs have an engineering degree than any other degree. Like more than business. Like more of them started in engineering than started in business. Because they knew it was a better path. And I'm like, oh, and by the way, just go look it up. Like every year, what are the highest salaries for bachelor's degrees? Every year, for years, engineering. Highest salary. Drop the mic, walk away. Okay, cool. Here we go, 11, look.
Wait, why did Mr. Reese get mad at that?
What's that?
Why did Mr. Reese get mad at that?
Oh no, he didn't get mad. He asked me to write an article, and I was just being a little bit arrogant, like, why would you study math? And he gave these arguments of like, well, here's a reason, that's all. Because I do think it's dumb that we make fun of it. Like I do think it's silly that people would, like it's fine if you don't like it, but you shouldn't discount it. Like, look, it's simple. Our world would not exist without this. Like you cannot design an airplane, a cell phone, a projector, a computer without calculus. It's not possible. Like it is not possible. Like you have to have all modern technology is at its core, there's calculus there. Like it could not have come about without it. Like there's just no way to solve the problem. That's why we didn't have it before. Calculus is not that old. It was only discovered like early 1700s.
Can you go deeper dive into the inner workings?
We can maybe talk. I don't say I'm any sort of expert, but I can kind of give you a little bit of background. Give you some. Here's where calculus came into play, and it wasn't like you just used calculus, but it's an element that without it, you're stuck. Like they just go, okay, now we know. All right. Quiet. We got to go a little bit quick. Come on. I firmly believe that math is not invented. Math is discovered. Math is truth. And we just have to find it. It's there. We just got to find it. Wow, that's all right. I like Einstein's quote. It says, God did not play dice with the universe. Like there's rules. Just follow the rules. You just don't know them all. All right. Hey, we need to find this integral. Quiet. We can't use our calculator. Raise your hand, please, everyone. Can you be honest? Can you see that if I'm trying to find the antiderivative of this formula, I'm not going to find a matching formula on the blue sheet? Hands up if you can see that. Like it does not match. So like Corbin said, 2 points for voting. Like Corbin said, we can't use the blue sheet. So your very next option is try to see if you can do a use substitution. So it's going to go faster this time. So Kenzie, first thought on use substitution is, do we have two functions multiplying? Kenzie?
Yes.
Yep, what are they?
X and then x squared plus 2.
Perfect. So now to Ava. So we've got x multiplied by x squared plus 2 squared. Two functions multiplied. Ava, are both of those functions of the proper form?
Yes.
Which form does the yellow take?
Well, technically the first one.
No, it's very good. It's absolutely the first one. What's the n, Ava?
1.
And what's the something?
It's the x.
It's the x. So on your paper, two for Ava. Over on the right here, over here, write down u could equal x. And then a frowny face.
Don't forget the frowny face.
Because that doesn't help anything. That doesn't help. So Lily, we go to the blue function. Which of the 5 forms does the blue function take? The first one. What's the n?
The n is 2.
What's the something?
X squared plus 2.
That's what we choose as u. 2 points for Lily. Let's go to Lissy. Lissy, the next thing we do is we take the derivative of our choice. So this becomes du dx. What will the right half become, Lissy?
It would be 2x.
Good. Is the derivative, so our choice of u here came from which of the two multiplying functions, first or second?
Second.
Good. The derivative of our choice, does it match the first multiplying function?
Yes, besides the constant.
Except for the multiplying constant, we're good.
Good.
So this is a good path.
Let's go.
2 for Lissy. Pretty good? So now we need to make substitutions. So this step is always the same. Let's multiply the dx across. So multiply the dx across. We'll go to Mitchell. Do I want to leave the 2 where it is, Mitchell, or do I want to move it to the other side? Well, to be fair, I'm trying to replace x dx.
Oh yeah, you want to do 1/2 du.
Very good. So go 1/2 du is the same thing as x dx. Now I'm making really good progress. Questions? Cool. Let's go to Lexi. We need to change these limits from x equals 0 to u equals something. Our formula for making the change is right here, Lexi. So if u is equal to 0, according to this formula, Lexi, what will u equal?
Just 2.
Nicely done. 2 points for Lexi. Let's go to Sophie. Sophie, if u is equal to, it says here 1, x is equal to 1. According to our formula, what will be the value of u?
3.
2 points. So we've got everything we need now to make all the substitutions. So come back over here. Piper will help me. I have the equal sign, because these are the same. What are my limits, Piper?
It's going to be the top is 3 and the bottom is 2.
Nicely done. When the x was 0, the u is 2. So when the x is 0, the u is 2. When the x is 1, the u is 3. 2 points. Let's go to Riley. Riley, we can replace x squared plus 2 with u. So that means this here can be replaced. So I'm going to write that down. I still have the x dx. What is x dx the same as, Riley? Look over here and find something that's the same as this green box. Perfect. 2 for Riley. So those are the same, so we can make that replacement. And we'll go to Brinley. What do we do now, Brinley? You're okay. So the 1/2 is a multiplying constant, so we can move that out front. Now look at your blue sheet. Do you have a formula for finding the antiderivative, Brinley, of u squared du? The power rule. So we're going to take and find the antiderivative of this. And what is that antiderivative according to that sheet, Brinley?
U squared plus 1
Nicely done. Keep going, Brinley.
over 2 plus 1.
2 points. We'll go to Tyler. Tyler, we have a formula here in green. We can't lose track of this. We have a formula here in green. We have a formula here in blue. How are they related? The blue is the antiderivative of the green. So now we can take those numbers and plug them in. 2 points for Tyler. Let's go to Jocelyn. So I'm going to clean this up a little bit, Jocelyn. Here we have 1 over 2 multiplied by something over 3. So those can multiply. It's 1 over 6. Let me just plug it in. So we get u, which is going to be 3 cubed. Subtract 2 cubed. What's 3 cubed, Jocelyn?
27.
And then 2 cubed?
8.
Perfect. 2 points. Is that one bad? Jocelyn, 27 minus 8 is?
19.
Okay, we're done. Still ain't that bad.
Why did we still keep the 1/6 on the outside? Like, why didn't we do like that whole equation times
1/6 and then again.
and then minus? You know what I'm saying?
Yeah.
Why did we?
Either way,
Would we do the same thing?
sure, because you're just factoring it out.
Oh, okay. Okay, that makes
So we can factor it through or factor it out. Same thing.
sense. Okay.
Does that make sense?
Yeah.
Work. Please. Please.
I'm kind of confused how we got from the blue to the purple.
You're okay.
The cube, where the cube.
So you're okay here?
Yeah.
So I'm going to write an extra step so you can see it better. Is that okay?
Yeah.
I just got to move this out of the way a little bit. Hey, you don't need to do homework yet because we're still trying to get everybody back together. So we'll keep working on this together. So, Paige, this is going to be 1/2, right?
Yeah.
Okay, right here, all I have are factors. I have a 1 on the top, 2 on the bottom, u cubed on the top, 3 on the bottom. Is that me? So I can put them in any order I want. So I'm going to go 1 over 2, multiplied by 1 over 3, multiplied by u cubed.
That's why we're really fast.
So this is u cubed divided by 3, which is no different than 1/3 times u cubed. So now I just choose to multiply those first. So that's 1/6. And then I have u cubed evaluated from 2 to 3.
What's that back? Track. You playing these first? You should give it a shot. Go for it.
No, let me show you what I mean.
I don't know. I think you should go for it.
In my opinion,
I don't know. It's still your fault. See you later. Thank you.
to get from here to here. Right, because the federal ships are already on the border.
It was like,
In green.
Yes, I'd actually know for like
Six, I know. In blue. I don't lose the this symbol means there's plugging in. So that's why I'm saying it.
that would be funny. How that's pretty good.
That's the government. It just looks like
Wait, and so you have 30 lines?
That's what I know.
I
Actually, miss it a lot.
So,
So those are about, we started with values of x.
because the whole argument is
Here.
TV shows have different plots.
No, we didn't.
Yeah, and so like that's why.
But we said, instead of doing this integral,
Go ahead, Mr. Riggs.
we're going to do an equivalent integral.
Oh my goodness.
I know.
Okay,
I
I
read
think
it.
that's that.
I read it last
Replace
night.
with
I was
something
like,
that is the same.
I would have done it like Sunday night.
So
and
what
I
we
would
did
have been
is we
Yeah.
I
said,
mean,
Oh my gosh.
yeah, thank you very much. I'm really glad you
you're
did.
going to declare
These things.
that symbol has the
Yeah, you
exact
have
same
on
meaning
campus
as
and
these
paper and-
symbols.
Yeah, I don't know.
Just get it done.
Like,
And
as
then
a
from
French
that, we
teacher and all,
built
but
other things.
some of the things.
We said, okay, so if that's true, then I can take the derivative of both sides, it still must be true. I can use algebra to rearrange, still must be true. So we discovered that, oh, hey, you know where I see an x times a dx? That's the same as 1/2
So
du.
it just kind of like.
It's a replacement. It's a replacement. You take one away and you put an
Oh,
equal
so
in
this is
1/2 du.
that
Go ahead.
for the x?
So what happened was, these two are multiplying, so I can multiply them in the other order.
Okay.
So I put this one first,
Yeah.
and then I put the x second.
Okay.
And then I still have the dx there. So that helped me see that x times dx is no different than 1/2 times du.
Gotcha. So that's why it's important that you like that this matches.
It has to match. The whole idea, like everything we do, is all based on, can you recognize when things are equal? And this is just recognizing that there are lots of things that are equal. X dx is equal to 1/2 du. X squared plus 2, we decided that would be just u itself. When x is 1, according to this formula, if your x value is 1, your y value has to be, not your y value, u value has to be 3.
Okay.
So we switched everything. Like when we get to here, x is gone.
So this
Go ahead.
u is like the formula, not actually x.
U is just another, they're all just symbols, but U is this new symbol that is related to the symbol we have.
So this is saying when x is 1, right?
When x is 1,
When x is 1, u meaning like this whole thing is
3.
3. Okay.
Another way you might say it is like this. Let's see if this helps the page. You're used to seeing formulas that say things like f of x equals, right?
Yeah.
Or you're used to seeing a formula that might say y is equal to x squared plus 2.
Yeah.
And then you don't have any trouble saying, okay, if my x has a value of 0, what's the y?
2.
And if my x has a value of 1, what's the y? We're doing the same thing.
Yeah.
We just didn't choose to use the letter y, we used the letter u.
Oh, okay. So u is like y.
It's just another symbol.
Okay.
We could have used w,
Okay.
but it wouldn't matter.
Okay. Yeah. So then we take u and so this like f of a, like this whole entire symbol, I'm thinking of as like u. Like, you know how like you do f of x?
Got it. That's over here actually. Like you could say y of 0 is what?
In relation to
According to this.
2.
Good. And then y of 1 is, and then we could say, based on this, we could say u of 0 is
2. Yeah.
2, and u of 3 is, oh sorry, u of 1.
1 is 3. Yeah.
There you go. You good with that?
Yeah.
Yeah, that's absolutely true. This is different though over here, because the f is representing something else. What we have to recognize here is, we had a formula right here, u squared. In this fundamental theorem, u squared is represented by f prime.
Because I understand how the squared is not part of u. Because like even though it's like x squared plus 2, like the squared is like
Yeah, it's something
like
operating
u
on
is
you.
like in and of itself.
It is.
So, but how
Stop
is